What we're going to be talking about is our types committee. Ding, 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 ding. Oh, here's a good saying by Larry Wall, aka Saint Larry, founder of Perl. The usability of a computer language is inversely proportional to the number of theoretical axes the language designer tries to grind. Well, this is one language axe that the designer, St. Larry, did not try and grind well enough. He left us without any real access to the well-hidden and somewhat questionable type system that Perl implements inside of its own interpreter, tucked away under the covers, so to speak. But what we don't have is access to real solid data types that correspond to the underlying hardware, as I had just mentioned a moment ago. So what does that have to do with anything? Well, it has to do with a lot, because if you don't have data types, you can't really compile your code. If you can't compile your code, you can't make it run fast. If you can't make it run fast, you can't get the non-compiled parts to run faster. And basically, it's like it's a cascading effect that leads you to lower quality, slower, outmoded styles of programming. And that, whether you guys want to believe it or not, that's what we've been stuck with for the entire lifespan of our beloved language Perl. So sorry if I'm raining on your parade, but hey, I'm not here to tell you lies. I'm here to tell you the truth. So that is the truth, and there are a number of aspects to the Perl Types Committee. It's called the Perl Types Committee because that's the basis of what we're doing, is the type system. So if you go to MetaCpan, if I can type it correctly. Hopefully MetaCpan's working. Boy, this thing's been buggy as all heck lately. And type in Perl types. Hopefully that's going to work. Hey, it actually worked. Okay, version 0.21. Yes! Complete with user documentation. Look at that. I am so proud of myself for finally releasing the Perl type system. Now this is a beta version, but it's a working beta. And it's something that everyone needs to start using immediately. And again, you may be asking why. Well, if you ever want your code to not be slow, not be buggy, not be unmaintainable due to data types not matching or being present at all, and if you ever want non-Perl programmers to be able to read your code and hate you slightly less, then this is pretty much your only hope to achieve that, I guess. You could use type constraints instead of a data type system, but that would, those are soft checks rather than hard checks. And so, as John was describing, they're meant to handle dynamic runtime behavior and cannot provide support for things like compile time optimizations and compiling and optimizing your code performance. So let's go ahead and leave this part as an exercise to the reader. Please, if you have not yet, go ahead and type cpan Perl types and get it installed. Take a look at the documentation here. All you have to do is type use types, or use Perl types, or use Perl : types, and then just say my integer $1 equals 42 instead of just my $I equals 42. That's as simple as it is for the time being. You just put the type right in there. That's it. We also have compound types, array refs of integers, for example. We also have strings, characters, numbers, booleans. And then array refs and hash refs of all of those, and compound ones as well, like a hash ref, an array ref of hash refs of strings or whatever. And you can generate compound references to objects as well, and we're working on auto-generating higher dimensional, n-dimensional data structures for high-performance computing purposes, and so forth. But you can see all the examples here of what you need to know, basically. We do provide constant data types as well, using the built-in constant pragma or operation, keyword, whatever you are supposed to consider this in Perl. Use constant. And then we do, again, provide the actual data type in there. These are the types provided by the Perl type system. And then you give it your data there. This is the only way to actually create immutable constants right now correctly, using the actual Perl interpreter, not some other wacky third-party thing. And then subroutines need to have their return types defined, and they need to have their input types defined here. So you can see this guy is a void return type, this is a number, and a string return type for these three different pi's are round, pi r squared, and p is pentagonal. Then the first one takes no input arguments, the second one takes a single number, and the third one takes a string and an integer as input. So again, these are extremely simple contrived examples, but they show you how you can actually use real data types in Perl now. It only took me since 2011. Is that a long time? I can't keep track anymore based on how messed up the Perl community is. But we're fixing that. We're fixing that. At some point, Bruce Gray is going to come be on our board of advisors. When that happens, we'll know we've won. Until then, we're still working on it. We're still working on it. So, meanwhile, you can set up objects. We also have provided a new constructor, a class constructor, and then you can create methods there. So we do. This does provide object orientation because objects are types. Objects are types, and objects contain inside of each object you have to define a type. In fact, that's something that's missing in the documentation, is all this extra stuff about, you can even see all the stuff that's coming soon. How to define classes is on that list. So this is very much a work in progress. There is non-documented functionality if you're adventurous and you want to check it out. GIMP integer, that's the GNU multi-precision library. So that's an arbitrary precision integer, a super duper long number with as many digits as you need to have. And other stuff too. And a bunch of other stuff. So check it out. And there's links to the compiler and the committee here and so forth. This is new, hot, and awesome and amazing. Please check it out. Ooh, it has a decent quality score, and I think it also has somewhat of a decent tester score. I don't know. Let's look. Let's find out, because this was a bug fix. Hey, look, it's not too bad. And I think I know what all these things are from autoconf, missing autoconf. I need to set up like alien autoconf, or maybe it was alien auto package. Anyway, it's some Unix utility that's not installed on the red ones, but it is installed by default on the green ones, and so I need to set up the alien package so that it installs it and makes it available on these red ones, and then it can build and configure itself correctly. This is because the type system is a technical thing that requires a lot of heavy lifting by underlying compilers and operating system components. So you have to have a good operating system. It is possible to get this working in virus loaders, proprietary operating systems like Microsoft or something like that. But it is really difficult. If you watched Brett's talk earlier, you can see all the crazy gyrations you have to go through to get regular Perl running in Windows, and then you have to do all kinds of extra stuff to get compilers and stuff working in there as well. So it's not easy to get complicated Perl stuff running in Windows. I'll just throw that out there. But it is doable in most Unix environments. You just basically you need a really good C and C++ compiler with all of the basic libraries that it's supposed to come with, and the ability to run completely unencumbered Perl. So that means like downloading and installing anything from CPAN, building and compiling anything on CPAN, running all these alien packages that are going to download and compile and install non-Perl things. It requires, again, like a robust, completely, fully functional operating system. And a lot of people in life are stuck with partially functional operating systems at best, and maybe it's because they don't realize it, or because they have to use it from their work computer or something. I don't know. But I mean, if you don't have a fully featured Unix environment, then you're shortchanging yourself as a programmer, I guess would be my advice in that regard. And unfortunately, if your thing has the word subsystem in it, or virtual in it, or anything that's not a direct installation of a Unix environment on your hard drive, then it's not real. I hate to tell you this. It's a fake thing to make you think you're cool and that you're a real programmer, but you're really not. Again, I'm not trying to be rude. I'm trying to help you guys understand what's real and what's not in the world. So these are real data types, and other things are not. Some operating systems are real operating systems. Others maybe less so. Okay, so that's the Perl type system, which you can see is represented right here with this word cloud with the pachyderm of peculiar data packs here. So arrays, integers, numerics, characters, all that stuff. Eventually even specialized types like time types or UUID types and stuff. Those can all be defined as, again, like objects, right? And if they actually, those would be either Perl objects if they do not correspond to underlying hardware data types, or they would be actual real types. If there's, I think there is a time T, for example, in C or C++, and I could be talking somewhat out of turn here because I'm not trying to look any of this up. I'm just going off the top of my head. But I'm pretty sure there's a time T, like a time type or something like that. And if not, there should be. But I'm pretty sure there is. So that would be something that we absolutely can create an interface to directly through the data type system, where that, for example, if you were going to try and define this in your code, you could do like my time and then dollar whatever the name of your thing is, and equals whatever. And that would be not only would that be understood by Perl as being a special type that has whatever features that it would have corresponding to the underlying C type, but it would be compilable directly into that actual C type. So it would be again a Perl interface directly to a real data type that exists, and that's compiled with the C compiler. Basically, our definition of a real data type is whatever C considers to be real enough to compile into some hardware container or package of some kind. And maybe that seems C-centric, and that's correct, because it is. C is the most important programming language in the world, if you didn't know that. All the other programming languages are derivative or subordinate in some way. And yes, I'm sure there are academic arguments against this, like, well, there was probably some language that came out before C, or, whatever, but not really. I mean, like, it was, Unix was 1971, C was 1972, or maybe I got those backwards, but I mean, that was it. There was stuff before that maybe, but it doesn't really matter because Perl is written in C. Java is written in C. Windows is written in C. Linux is written in C. Pascal is written in C. C++ is written in C. BSD, FreeBSD is written in C. C is written in C. C is a bootstrapping language, so it's written in itself generally, depending on what C compiler you use. Usually they don't write the C compilers in assembly code anymore. And even assemblers are like often written in C or whatever. So all of the most critical components from operating system kernels to the compilers themselves and the interpreters like Python is written in C and Ruby and so forth, all of those are all written in C. So interpreters tend to be written in C, compilers, everything important, virtual machines, all of those things, operating systems, everything. This is because C is where the greatest optimization can occur, so anything that has to run fast probably needs to be written in C at some point or compiled somehow into C. And also, it's because it's where the most man years of effort have gone into in the whole world. So I mean, if you just look at every language that's existed and how much effort has gone into optimizing it and making it work on every different computer, C wins by a lot. So that means like C will run on most anything, and it will run faster than most anything, and I mean, just those two things make it the critical sort of default choice for any program that needs to either A, run on a variety of hardware, or B, run at a decent speed. And since that encompasses a tremendous amount of critical system and application software, then that just means C is king. So I don't ever believe we're going to do away with C, and I wouldn't probably want to, but I don't particularly like writing C code myself, and I've had to do it for years, ever since I started, I guess, being a programmer, but more especially working on the Perl compiler and the data type system, because again, Perl is written in C, or more specifically like C89 macros, so it's like super duper old copy of C language specification, and much of which is in macros, which are preprocessor directives that are not fun to deal with and are generally a mess. And all of that is, of course, building up to create the king of all messes, XS, which is the sort of Perl's internal language, I guess, and that's a horror show of incomprehensible bullcrap that you have to understand in order to ever try and understand any tiny piece of the Perl interpreter in any way. And boy, it's a headache. It's a huge problem. The Perl interpreter is a problem. So, and plus it's slow, super slow for almost everything except for like regular expressions, and the regular expression engine is kind of a separate piece of the interpreter anyway. So really, I mean, just the interpreter is slow. That's it. It's like hundreds of times too slow. So I don't really want to write code in C, and I don't really want my code to run super slow, so I just invented a compiler. Why not? I guess I can do that because I'm smart. So RPerl is the name of the Perl compiler, and it's as you can see here, the type of compiler is it's a static optimizing compiler for Perl. Perl is a dynamic language, but what we're doing is we're targeting the static subset of Perl, the parts that are best compiled, the parts that are easiest to compile, and the parts that receive the, thank you Bruce, the parts that receive the most benefit by being compiled. And so let's just say that, I don't know, it's 50% of the language. I'm just throwing that out there as a random number, but let's just say that 50% of the language is static and 50% is dynamic, just for the sake of argument. I don't really know what it is, and it's probably not 50-50, and I suspect that it's more like 20-80 or 30-70 or something, with the smaller part being the static part. But nevertheless, that's a difficult number to come up with, because this is all still experimental and it's all still being figured out and worked on and developed actively. So nevertheless, just for the sake of argument, let's say that half of Perl's features can be compiled and optimized easily or readily somehow, and the other half cannot. So for example, like a simple if-then statement or loops, or even regular expressions can generally be compiled, believe it or not. Something like a stringy eval or a purely runtime behavior like calling out to an external system command, or opening a database, reading and writing to a database when you don't know what's in that database. You can't really, you can compile the database access, and in fact we do support that, but you can't optimize what's going to happen based on what's in that database, for example, because you won't know until runtime. So those are just some examples of runtime behavior versus compile time behavior. But with the compiler, you have to know how to use the data type system, because the data type system is used to build the compiler. That's why this kind of goes in order. It's a three-tier system. So the first tier is the Perl types, that's the data type system. The second tier is RPerl, that's the compiler, and that'll probably be just renamed at some point. And then also the third and final level, which we have not built yet on top of the compiler, is the new virtual machine. And so what does that get us? Well, I mean, a lot, because this is the remainder of what we are trying to compile. This is the other 50%. Okay, so the data types is not actually compiling anything, but it's the critical step you must do before you compile. Then the compiler compiles, let's just again say, half of your code, and then the virtual machine handles the other half. So the compiler is compiling the static half of your code, and then the virtual machine is running the dynamic half of your code over here. So the static half gets compiled, the dynamic half gets executed. And really the virtual machine is probably going to use like a just-in-time compilation, so it is kind of compiling little bits of your code, but it doesn't know how to compile it all at once, because again it's runtime behavior, and it's unpredictable is what that means. And then also you will probably have still parts that need to be interpreted, and maybe some other parts that anything, maybe your parts of your code or other people's code that you're using that does not have the data type system enabled at all, then that's never going to be able to be compiled, or at least we could try and automatically guess at what the type systems are, and maybe even using AI and all of that sort of futuristic stuff, so I shouldn't say never say never. But you wouldn't be able to compile it using traditional static compilation analysis, because you need the types enabled to do that. So it remains as a three-tier system with the data types, then the compiler, and then the virtual machine in that order. So yes, that's the basic overview of the data type system. And it's almost time for us to go into our next lightning talk. So in fact it is time, because it's 3:35 right now. So I'm going to stop there. Thank you everyone for joining us for our first long-winded lightning talk. And I'm going to go ahead and unshare my screen. Please come see us every other Thursday at 1 p.m. Central Time Zone for our Perl data types